Across an unimaginable expanse of space and time, two colossal black holes, ghosts of ancient stars, spiraled together in a final, violent dance. Their immense gravity warped space-time, sending out ripples, gravitational waves that traveled for 10 billion years before reaching Earth on November 23, 2023. What we detected was more than a signal, it was an echo from a universe still in its infancy when galaxies were just forming. This event, GW231123, is the largest black hole collision ever observed, a true cosmic monster. It challenges everything we thought we knew, pushing us to ask new, daring questions about the life and death of stars. For a brief moment, Earth became a cosmic ear, listening to a symphony that began before our sun was born. Gravitational wave astronomy has opened a new window, letting us perceive the universe's most hidden and violent events. GW231123 is an invitation to rethink what's possible in the cosmos. Picture the protagonists not ordinary black holes, but titans, one with the mass of 100 suns, the other 140. These giants, born in a distant, ancient galaxy, merged when the universe was young. In their final moments, they unleashed more energy in a tenth of a second than all the stars in the observable universe combined. About 15 solar masses were converted directly into gravitational waves, a shockwave in spacetime 20 times stronger than most signals ever detected. The result? A single black hole of 225 solar masses, spinning 400,000 times faster than Earth. This is the largest stellar mass black hole ever detected by gravitational waves, shattering previous records. It sits between the black holes we know and the supermassive ones at galactic centers, a new class of cosmic object. Every number associated with GW231123, the masses, the energy, the distance, paints a picture of a universe far more extreme than we imagined. This event is a spectacular benchmark, redefining what's possible in the cosmos. We're not just inching forward, we're leaping into uncharted territory. GW231123 is a paradigm shift in our understanding of black holes. Detecting such a faint signal from so far away is a triumph of technology. The LIGO Virgo Kagra (LVK) network, spanning the US, Italy, and Japan, doesn't look for light, but listens for spacetime's vibrations. Each detector uses kilometer-long tunnels and lasers to sense distortions smaller than a proton's width. When a gravitational wave passes, it knocks the lasers out of alignment, letting us hear the cosmos. Multiple detectors allow scientists to pinpoint where in the universe the event occurred. The addition of Kagra in Japan further boosts sensitivity and reduces noise. Upgrades in 2023 pushed the detectors beyond previous limits, letting us hear fainter, more distant events. This relentless innovation lets us witness cosmic events once thought purely theoretical. GW231123 isn't just exciting, it's deeply puzzling. According to current theories, black holes this massive shouldn't form from single stars, they should be limited by pair instability supernovae. Yet here are two black holes, one at 140 solar masses, defying that limit. The leading theory, these are second-generation black holes built from previous mergers in dense star clusters. GW231123 is spectacular evidence for this cosmic assembly line, forcing astrophysicists to rethink how black holes grow. It's a mystery that shows our story of the universe is still incomplete. The magnitude of GW231123 sent shockwaves through the scientific community. At the 2025 Glasgow conference, awe and excitement were palpable. This discovery pushes the limits of our understanding. Scientists like Mark Hannum and Sophie Binney captured the thrill. Every answer leads to deeper questions. GW231123 isn't an endpoint, but a signpost to new cosmic mysteries. The LVK collaboration, over 1,000 scientists worldwide, made this possible, showing the power of global teamwork. These discoveries remind us that science is a profoundly human adventure, filled with wonder and perseverance. Modern astronomy is open to all. The LIGO Virgo Kagra team shares its data through the Gravitational Wave Open Science Center, GWOSC.org. Anyone, student, educator, or enthusiast, can access the same data that led to this discovery. Tutorials and tools help you visualize signals, explore hundreds of events, and even analyze data yourself. Join the conversation online, share your excitement, and connect with a global community of cosmic explorers. Science thrives on collaboration, and your curiosity is part of the journey. This is your invitation to step onto the cosmic stage and be part of the adventure. Discoveries like GW231123 expand our sense of what's possible and illuminate the vastness of our ignorance. Each gravitational wave is a messenger from a hidden universe, full of surprises and wonders. This journey is driven by the same curiosity that led our ancestors to explore the unknown. GW231123 connects us to the deep history of the cosmos and inspires the next generation of explorers. With creativity and collaboration, we can achieve the seemingly impossible, like hearing a collision from billions of years ago. The horizon of discovery keeps expanding with every new question and answer. The universe is speaking, and for the first time, we're learning how to listen.